Hey guys, this is Mrs. Lyons. This video is to help you uh, figure out predicting products for synthesis reaction and then a little bit of balancing practice also. Okay, so this is just supposed to be a helpful video, hopefully, to get you some practice. All right. So I'm going to move this in a little bit closer. There we go. Okay. So this worksheet that I'm working on now is just synthesis reactions. Okay. And we can tell that they're synthesis because we have two elements. And even without the product given, anytime you just have two elements, that's going to be a synthesis reaction. Okay. So we're just going to practice balancing these to start with. And I'm going to balance them in the most simple way. Some of you are really good already at just balancing these by looking at them. But this is one way. And there is actually going to be a question on the quiz and on the test that asks you to draw a model of an equation. So this is something that you would draw as a model. Okay, so we start with P4 and Cl2. So I'm just going to write P4, okay, plus Cl2, okay. So I'm just writing out the number of atoms that I have. I'm making sure that they're connected to show me that each of those is a compound. Okay, and then here I have PCl5. 1, 2, 3, 4, 5 CLs. All right. So this is a very busy one to start. But if I count over here, I have 1, 2, 3, 4 phosphorus. Over here, I only have 1. You know what that means? I need 3 more of this whole compound. So P, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can kind of see why this gets to be a really long way of balancing. I'll show you in a minute. I'll actually show you the other way of balancing this, okay? Because now if we count, we've got to count how many chlorines, because we've got 1, 2, 3, 4, 1, 2, 3, 4 phosphorus, okay? Here we've only got 2 chlorine. Here we have 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so to get 20 chlorines here, so I've got 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oops, and I got all the way off of my paper. There we go. Okay, so now I have the same number of chlorines and the same number of phosphorus. So I have 1 of these P4s. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Cl2s and 1, 2, 3, 4 PCl5s. Okay, now I'm going to, on a separate sheet of paper, I'm going to write this and I'm going to show you a different way to do the same thing. All right. And honestly, I don't care which way you do it. You've got to get done with the test or the quiz during the class period. So you've got to find a way that you can do quickly. Okay. This way is where I put a list of the elements and I have to count. So here I have 4 phosphorus. So on this side, I put 4. So I've got 4 phosphorus. Uh-oh. My camera wants to be blurry. What the heck? There we go. Hopefully it'll stay that way. Okay, so I have 4 phosphorus. Over here, I have 1 phosphorus on the product side. All right, here I have 2 chlorine. Here I have 5 chlorine. Okay, so if I look at this, if I have 4 phosphorus here and only 1 here, if I put a 4 in front of that PCl5, and remember, if there's not a subscript, it's like there's a 1. All right, so this means I've got 4 times 1 is 4 phosphorus. All right, we also have to count our chlorine, so 4 times 5 gives me 20 chlorine. Okay, so my phosphorus is balanced, my chlorine is not. So I have a Cl2. So I have to think, what do I have to put here to give me 20 chlorines? So I need something times 2 is 20, so that is going to be 10. 10 times 2 is 20. So now my equation is balanced. All right, so 1, 10, 4. All right. So let's look at another example. I'm going to move this up a little bit and see if it doesn't quit being goofy. All right. I picked worksheets with really big numbers of things, but that's okay. All right. So here we have copper plus. What in the world is going on with this thing today? All right. Sorry about that. I've been doing this for days and not had this issue, and all of a sudden. All right. So I have copper plus sulfur, and I know that we've talked about things only being 1 in synthesis reactions, but sometimes there are compounds, molecules that are a little bit different. We just pick the easier ones for us to predict. We know that this is synthesis because it's 2 elements forming 1 compound. All right, so I have copper and I have S8. 1, 2, 3, 4, 5, 6, 7, 8. And then on the other side, I have CuS. So I have CuS. Okay, this one's not quite so bad because I've got 1 copper on each side, but then I've got 1, 2, 3, 4, 5, 6, 7, 8. So what I need is 8 of these, because each one of them gives me a copper. 1, 2, 3, 4, 5. 6, 7, 8. All right. So now 1, 2, 3, 4, 5, 6, 7. I've got 8 sulfur. I've now got 1, 2, 3, 4, 5, 6, 7, 8 copper. Now, when it's just an element, I don't know if it's necessary for you to write this out. I certainly would not require you to. I don't need you to show any work for balancing, but if you really like that visual, that's absolutely fine. Okay, so what we are going to have for coefficients here is 1, 2, 3, 4, 5, 6, 7, 8, 1, and 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. And I'm just going to kind of alternate back and forth with methods that I'm using, okay? Because it truly is up to you what works best for you and your brain, okay? So this one, I have Fe plus O2. And again, it's really good to know how to kind of write these this way because it will help you answer that modeling question. All right, here I have Fe2O3. So Fe, Fe, O, O, O. All right. Since iron is by itself, I'm going to wait until the end to do that. But if I look here, I've got 2 oxygen. Here I've got 3 oxygen. So this is one of those situations where we need to get to 6 because 2 and 3 both go into 6. So I've got 2. If I do one more of those, I've got 4. If I do one more of those, I've got 6. Okay, so 3 O2s. Over here, if I add one more FeO3, now I have 1, 2, 3, 4, 5, 6 oxygen. Okay, so my oxygens are balanced. Here I have 1, 2, 3, 4 iron. All right, so now my equation's balanced. I have 4 iron, I have 3 O2, and I have 2 FeO3. All right, from my balanced equation. All right. Let's see. This one, I'm going to try to do using the number in the middle method. So I have phosphorus and I have sulfur. Here I have 4 phosphorus and I have 8 sulfur on the reactant side. On the product side, I have 2 phosphorus and 5 sulfur. Yes, 5. All right. So this one already looks like it's going to be a little bit of a doozy because I've got 8 and 5. So what is the least common multiple of 8 and 5? 40. Okay, right? That's the smallest number that 8 and 5 both go into. So for my sulfur, I'm going to want to put a number here that gives me 40 sulfur. So what times 8 is 40? That would be 5. Okay, so now I have 40 sulfur on this side. Over here, I have 5. So I know that 5 times 8 is 40. All right. But that also gives me, if I look, 8 times 2 is 16 phosphorus. All right. Over here, I have 4. So if I put a 4 in front of here, 4 times 4 gives me 16 phosphorus. Okay. All right, one more balancing. And it's not a terrible crazy one, I guess. I picked some big ones, didn't I? All right, so let's write this out. Actually, let's just kind of try the line it up way, just because drawing 8 sulfurs is a lot. So this is S8, so I've got 8 sulfur. O2, I have 2 oxygen. Here I have 1 sulfur and 2 oxygen. All right. Oh, this one's not terrible. I need to have 8 sulfur over here. So if I put an 8 in front of the SO2, that gives me 8 sulfur. 8 times 2, that gives me 16 oxygen. Okay. So now I have 8 sulfur on each side, so that's balanced. I just need to balance my oxygen. So here I have 2. What do I multiply by 2 to get 16? 8, right? 8 times 2 is 16. So now sulfur is balanced, oxygen's balanced, my equation is balanced. Okay. All right. So this next group asks us to predict products. Okay. And I know some of you have kind of struggled with this. All right. So we're just going to take a step back and do just some synthesis. You know it's synthesis because it's just 2 elements reacting. Okay. Those 2 elements are going to combine. Okay. And what we want to do is we want to look at the periodic table and look at the charges. And of course, every time I come home, I leave my periodic tables at school. So you will have to look at your periodic table and check me, make sure I'm not making any mistakes. All right. But when you have a synthesis reaction, what you're going to do, and I'm going to do it over here so that I can just put my answer in the blank. What you want to do is you want to combine the 2 elements. So magnesium plus oxygen. Okay. The subscripts from the reactant side do not go to the product side. The way that you figure out the subscripts over here is to look at the charges on the periodic table. Okay, so magnesium is in group 2, it will form a +2 ion. Oxygen is in group 16, it will form a -2 ion. Now, since those are both 2s, they cancel out, and we get MgO. All right, and I'm just going to kind of go through balancing these by inspection on this one, just by kind of seeing if I can do it just by looking at it. Okay, so if I look, I have 1 magnesium here, 1 magnesium here, so that's balanced. I have 2 oxygens here and only 1 oxygen over here. So I'm going to put a 2 in front. All right, so now my oxygen's balanced, but now I have 2 magnesium, so I need to add a 2 over here as well. Okay. When you do these on a quiz or a test, you will be asked to include the states. And I think you guys have been pretty good about knowing what's what in terms of the states. All right. All right. The second one is lithium plus nitrogen. So again, I'm going to write lithium and nitrogen over here. I have to look at the charges. So on my periodic table, lithium has a +1 charge, nitrogen has a -3 charge, okay? Which means if I crisscross these, this 1 comes down for the nitrogen and the 3 for lithium, so it gives me the compound Li3N, okay? Notice I don't have any charges in my with my subscript, and I don't have to write the 1. It's just assumed, okay? If you want to write it, I won't count it wrong. So if I look at this, on this side I have 2 nitrogen, on this side I only have 1, okay? Which means I need to put a coefficient of 2 here. So 2 times 1 gives me 2 nitrogen, all right? For the lithium, I now have 2 times 3, which is 6 lithium. So if I put a 6 here, my equation is balanced. Okay, lithium is a solid, nitrogen is a gas. Ionic compounds are always going to be solids. Okay. All right, potassium plus oxygen. So that is going to give me KO. All right. If you look on your periodic table, potassium will form a +1 ion. Oxygen will form a -2 ion. So if I crisscross, I get K2O. All right, it's going to be a solid. And again, if you look at this one, on the reactant side, I have 2 oxygen. On the product side, I only have 1. Okay, that 1 is there. We just don't write it. So what that means is I need to put a 2 here. So now this means I have 2 oxygen, but I now have 2 times 2 is 4 potassium. So if I put a 4 over here, I am balanced. Okay. All right. Aluminum plus oxygen. So I'm going to form a compound of aluminum and oxygen. I have to look at my charges. Aluminum has a charge of +3. Oxygen has a charge of -2. If I crisscross those, I get Al2O3. All right. Here's one of those examples where you have a 2 on one, 2 oxygen on one side, 3 oxygen on the other. So we have to find that least common multiple of 6. So to get 6 oxygen, I would have to multiply my oxygen times 3. I would have to multiply this compound times 2, because 2 times 3 is 6. Now I have 2 times 2 is 4 aluminum. So a 4 goes over here. All right, one more. Barium and fluorine. So I'm going to come over here. My compound is going to be BAF. I have to look at my charges. Barium forms a +2 ion. Fluorine forms a -1. If I crisscross those, I get BAF2. It's going to be a solid. Okay. Notice this one's sweet because I've got 1 barium on each side. I've got 2 fluorines on each side. So this is already balanced. Okay. All right. Now, you will have to do this once on the test and once on the quiz. You will have to take a word equation and write a chemical equation. Okay. And it's not bad. Okay. So we have aluminum reacts with oxygen to form aluminum oxide. Okay. So aluminum is a metal. Aluminum is a solid. Okay. It is, I guess we should write down, now that we're doing this, we should write down our 7 diatomic elements. Okay, Hoberfinkel. That's the word I make out of the 7 diatomic elements. So when we're writing just an element, okay, not a compound, we have to think about that. So aluminum is not one of the 7, so it's just Al. It's a solid because it's a metal. Reacts with is where we put our plus. Oxygen, all right, oxygen is one of the 7, so oxygen is O2. We know that oxygen is a gas. All right. To form, that's where we put our arrow. You guys, if you don't include your plus sign in your arrow, that's actually, you actually get a point on the quiz and on the test for writing those. Okay, so just keep that in mind, because I need, the plus tells me that this is 2 different things. All right. The arrow tells me that these are the products over here. All right. So aluminum oxide is a compound made of aluminum and oxygen. And we actually just did this reaction up here. If you look, aluminum forms a +3 charge, oxygen a -2 charge. If I crisscross, I get Al2O3. It's going to be a solid. All right. This is like we just balanced this. So a 3 here, a 2 here, a 4 here. All right. One more synthesis. Metallic zinc combines with sulfur to form zinc sulfide. All right. So zinc is Zn. It's a metal, so it's a solid. Combines with is where we put our plus sign. Sulfur. Sulfur is not one of the 7. So for us, we just leave sulfur as it is. We don't give a subscript. Okay. And sulfur is a solid. To form means we put our arrow. Zinc sulfide. So I'm making a compound made of zinc and sulfur. Remember, zinc always forms a +2 ion. Sulfide is -2. So this is already, those 2's cancel out, and we end up with ZnS, solid. And check it out, it is already balanced. All right, guys, so synthesis. Hopefully that helps. It gives you something to look at, something to practice. I will see you in class. Take care of yourself.